So we have seen this kind of a simultaneous assignment where we take three names on the left and assign them to three values on the right, and we enclose these in these round brackets. So this kind of a sequence of values with a round bracket is called a tuple. So normally we talk about pairs, triples, quadruples, but in general when it goes to values of k, we call them k tuples. Now in Python, tuples are also valid values. You can take a single name and assign it a tuple of values. For instance, we can take a two-dimensional point with x coordinates 3.5 and 4.8 and say that point has the value 3.5, 4.8, and this is not a list but a tuple, and we will see in a minute what the difference is. Similarly, we can say that a date is made up of three parts: a day, a month, and a year, and we can enclose this into a three-valued or triple. So tuple behaves like a list. So it is a kind of sequence. So like strings and lists, in a tuple you can extract one element of a sequence. So we can say that the 0th value in point is the x coordinate. So this would assign the value 3.5 to the value x, to the name x coordinate. Or we can take a slice. We can say that if we want only 7 to and 2013, we take date and take the slice from 1 till the end, then we will get 7, 2013. Right? So this behaves very much like a different type of sequence, exactly like strings and lists we have seen so far. But the difference between a tuple and a list is that a tuple is immutable. So a tuple behaves more like a string in this case. We cannot change, for instance, this date to 8 by saying date at position 1 should be replaced by the value 8. This is possible in a list but not in a tuple. So tuples are immutable sequences, right? And we will see in a minute why this matters. So let's go back to lists. So a list is a sequence of values, and implicitly there are positions associated with the sequence, starting at 0 and going up to the length of the list minus 1. So an alternative way of viewing a list is to say that it maps every position to the value. In this case, the values are integers. We can say that this list L is a map or a function in the mathematical sense from the domain 0, 1, 2, 3, 4 to the range of integers. And in particular, it assigns L0 to be 13, L4 to be 72, and so on, where we are looking at this as a function value. So the program language way of thinking about this is that 0, 1, 2, 3, 4 are what are called keys. So these are the values with which we have some items associated. So we will search for the item associated with 1 and we get back 46. So we have keys, and the corresponding entries in the list are called values. So a list is one way of associating keys to values. So we can generalize this concept by allowing keys from a different set of things other than just the range of values from 0 to n minus 1. So the key, for instance, could be a string. So we might want a list in which we index the values by the name of a player. So for instance, we might keep track of the scores in a test match by saying that for each player's name, what is the value associated. So Dhawan's score is 84, Pujara's score is 16, Kohli's score is 200. We store these all in a more generic list where the list values are not indexed by position but by some more abstract key, in this case the name of the player. So this is what Python calls a dictionary. In some other programming languages, this is also called an associative array. So you might see this in the literature. So here is a store of values which are accessed through a key which is not just a position but some arbitrary index. And Python's rule is that any immutable value can be a key. So this means that you can use strings which are immutable, and here for instance you can use tuples, but you can't use lists, as we will see. And the other feature of a dictionary is that like a list, it is mutable. We can take a value with a key and replace it. So we can change Pujara's score if we want by an assignment to 72, and this will just take the current dictionary and replace the value associated with Pujara from 16 to 72. So dictionaries can be updated in place and hence are mutable exactly like lists. So we have to tell Python that some name is a dictionary and is not a list. So we signify an empty dictionary by curly braces. So remember, we use square brackets for lists. So if we want to initialize that dictionary that we saw earlier, then we would first say test1 is the empty dictionary by giving it the braces here, and then we can start assigning values to all the players that we had before, like Dhawan and Pujara and so on. So notice that all these three sequences and types of things that we have different. So for strings, of course, we use double quotes or single quotes. For lists, we use square brackets. For tuples, we use round brackets. And for dictionaries, we use braces. So there is an unambiguous way of signaling to Python what type of a collection we are associating with a name, so that we can operate on it with the appropriate operations that are defined for that type of collection. So once again, for a dictionary, the key can be any immutable value. That means your key could be an integer, it could be a float, it could be a bool, it could be a string, it could be a tuple. What it cannot be is a list or a dictionary. So we can't have a value indexed by a list itself or by a dictionary. So we can have multiple, just like we have nested lists, where we can have a list containing lists and we have two indices. Take the 0th list and then take the first position in the 0th list. We can have two levels of keys. So if we want to keep track of scores across multiple test matches, instead of having two dictionaries, we can have one dictionary where the first key is the test match, test 1 or test 2, and the second key is the player. So with the same first key, for example, with the same different first key, for example, test 1 and test 2, we could keep track of two different scores for Dhawan, the score in test 1 and the score in test 2. Okay? And we can have more than one player in test 2, like we have here. We have both Kohli and Dhawan in test 2. So if you try to display a dictionary in Python, it will show it to you in this bracket, in this kind of curly bracket notation, where each entry will be the key followed by the value separated by the colon, and then this will be like a list separated by commas. And if you have multiple keys, then essentially this is one whole entry in this dictionary. It says for the key test 1 I have these values, for the key test 2 I have these values, and internally they are again dictionaries, so they have their own key values. So let's see how it works. We start with an empty dictionary, say score, and now we want to create keys. So supposing we say score test 1, Dhawan equal to 76. Now this is going to give us an error because we haven't told it that score test 1 is supposed to be a dictionary. So it doesn't know that you can further index it with the word Dhawan. So we have to first tell it that not only is score an empty dictionary, so is score test 1, and presumably since we will use it, so is score test 2. And now we can go back and set Dhawan's score in the first test to 76, and maybe we can set it in the second test to 57. Maybe we can set Kohli's score in the first test to 200. And now if we ask it to show us what score looks like, we see that it has an outer dictionary with two keys, test 1, test 2, each of which is a nested dictionary. In the nested dictionaries, we have two keys, Dhawan and Kohli, which score 76 and 200 as the values. And test 2 has one dictionary entry with Dhawan as the key and 27 as the value. So if we want to process a dictionary, then we would need to run through all the values. And one way to run through all the values is to extract the keys and extract each value by turn. So there is a function d.keys which returns a sequence of keys of a dictionary T. And the typical thing we would do is for every key in d.keys, do something with t square bracket k. So pick up all the keys. So this is like saying for every position in a list, do something with the value at that position. This is saying for something for every key in a list, do something with the value associated with that key. Now one thing we have to keep in mind, which I will show you in a minute, is that d.keys is not in any predictable order. So dictionaries are optimized internally to return the value with the key quickly. So it may not preserve the keys in the order in which they are inserted. So we can't predict anything about how d.keys will be presented to us. So one way to do this is to use the sorted function. So we can say for k in sorted d.keys, process dk, and this will give us the keys in sorted order according to the sort function. So sorted L is a function we haven't seen so far. Sorted L returns a sorted copy of L. It does not modify L. What we have seen so far is L.sort, which is a function which takes a list and updates it in place. So sorted L takes an input list, leaves it unchanged, but returns a sorted version of that list. The other thing to keep in mind is that though it is tempting to believe that d.keys is a list, it is not a list. It's like range and other things. It's just a sequence of values that you can use inside a for. So we must use the list property to actually create a list out of d.keys. So let's validate the claim that keys are not kept in any particular order. So let's start with an empty dictionary. And now let us create for each letter an entry which is the same as that letter. So we can say for L in A, B, C, D, E, F, G, H, I, D, I, D, L is equal to L. So what is this saying? So when you say for L in a string, it goes through each letter in that string. It's going to say D with the key A is the value A, D with the key B is the value B, and so on. Right? So now if I ask it what is DA, it will tell me it's A. If I ask it what is DI, it will tell me that. Now notice that the keys were inserted in the order A, B, C, D, E, F, G, H, I. But if I ask for D.keys, it produces it in some very random order. So E is first and A is way down and so on. There's no specific order that you can discern from this. So this is just to emphasize that the order in which keys are inserted into the dictionary is not going to be the order in which they are presented to you through the keys function. So you should always ensure that if you want to process the keys in a particular order, make sure that you preserve that order when you extract the keys. You can't assume that the keys will come out in any given order. So another way to run through the values in a dictionary is to use d.values. So d.keys returns the keys in some order. d.values gives you the values in some order. So this is for example like saying for x in L or something, right? So you just get the values, you don't get their positions. So here you just get the values, you don't get the keys. So if you want to add up all the values, for instance, from a dictionary, you can start off by initializing total to 0, and then for each value you can just add it up. It should be S, right? So you can pick up each S in test1.values and add it to the total. So you can test for a key being in a dictionary by using the in operator, just like lists. When you say x in L for a list, it tells you true if x belongs to L, the value x belongs to L. It tells you false otherwise. The same is true of keys. Right? So if I want to add up the scores for individual batsmen, but I don't know if they batted in each test match, so I will say for each of the keys, in this case Dhawan and Kohli, initialize a dictionary, which I have already set up, not here. I would have said that total is a dictionary. So total with key Dhawan is 0, total with key Kohli is 0. Now for each match in our nested dictionary, okay, if Dhawan is entered as a batsman in that match, so if the name Dhawan appears as a key in the score for that match, then and only then do you add a score, because if it doesn't appear, it's illegal to access that value. So this will one way to make sure that when you access a value from a dictionary, the key actually exists. You can use the in function. So here is a way of remembering that a dictionary is different from a list. If I start with an empty dictionary and then I assign a key which has not been seen so far, in a dictionary there is no problem. It's just equivalent to inserting this key in the dictionary with that value. If D0 already existed, it will be updated. So either you update or you insert. So this is in contrast with a list, where if you have an empty list and then try to insert at a position which does not exist, you get an index error. So in a dictionary, it flexibly expands to accommodate new keys or updates the key depending on whether the key already exists or not. So to summarize, a dictionary is a more flexible association of values to keys than you have in a list. The only constraint that Python imposes is that all keys must be immutable values. You can't have keys which are mutable values, so you cannot use dictionaries or lists themselves as keys. But you can have nested dictionaries with multiple levels of keys. The other thing is that we can use d.keys to cycle through all the keys in the dictionary, and similarly d.values. But the order in which these keys emerge from d.keys is not predictable. So we need to sort it or do something else if we want to make sure we process them in a predictable order. So it turns out that you will see that dictionaries are actually something that make Python a really useful language for manipulating information from text files or tables. If you have what are called comma separated value tables taken out of spreadsheets, because then we can use column headings, accumulate values, and so on. So you should understand and assimilate dictionaries into your programming skills, because this is what makes Python really a very powerful language for writing scripts to manipulate data.